Imagine planting something once, just once, and harvesting from that same patch every autumn for the rest of your life. No replanting, no purchased seed, no fertilizer, no irrigation. The plant simply returns year after year, producing more food per acre than potatoes, more calories than wheat in cold climates, and doing it all on soil that most crops would refuse entirely. This plant's real. It's growing in roadside ditches and forgotten field margins across North America and Europe right now. Most people walk past it without a second glance. It's called the sunchoke, and it may be the most underestimated food plant on Earth. Long before European settlers arrived in North America, indigenous nations across the eastern woodlands and Great Lakes region had built a quiet but reliable food system around a perennial sunflower relative. The Algonquin called it Kaishuk panic, the sunroot. It wasn't a supplement to their diet. In many regions, it was a foundation of it. The plant itself is dramatic above ground, growing 8 to 10 feet tall, crowned with cheerful yellow flowers that track the sun across the sky. But the real story happens underground. Beneath each plant, a network of knobby tubers spreads through the soil, storing energy as inulin rather than starch. A single established plant can produce 3 to 6 pounds of tubers. A well-managed patch can feed a family through winter. Leave fragments of tuber in the ground after harvest, and the plant returns stronger the following year. No human intervention required. When French explorer Samuel de Champlain encountered the plant in 1605, he was served it at a feast by his Algonquin hosts. He tasted it, recognized its potential immediately, and brought tubers back to France. Within a generation, the sunchoke had spread across Europe, not as a luxury, but as a lifeline for populations struggling with exhausted soils and recurring food shortages. Early modern Europe received the sunchoke at precisely the right moment. The potato, which would eventually dominate European agriculture, was still regarded with deep suspicion, widely believed to cause disease, resisted by farmers and consumers alike. The sunchoke faced no such prejudice. It spread rapidly through France, Italy, and beyond. Peasants discovered that a handful of tubers planted in spring required nothing further. No weeding, no watering, no purchased inputs of any kind. By autumn, the ground was loaded with food. Leave some tubers in the soil, and the following year's crop established itself automatically. It was, by any practical measure, a self-renewing food system available to anyone with a patch of ground. The numbers that later agricultural researchers would document are striking. Sunchoke yields on typical farmland reach around 30,000 calories per acre. Potatoes under good conditions produce roughly 20,000. In cold climates where potato yields drop significantly, the gap widens further. The sunchoke tolerates frost that would destroy a potato crop, survives drought on far less water than corn, and grows in compacted, poor, or marginal soils where most annual crops simply fail. For subsistence farmers, smallholders, and anyone operating without reliable access to seed markets or agricultural inputs, this combination of traits was extraordinary. The sunchoke asked almost nothing and gave back reliably. The plant's resilience was tested most severely during the 20th century's wars. During the First World War, Germany's food supply was severely disrupted by naval blockade. The winter of 1916 became known as the Turnip Winter, a period of genuine, widespread hunger during which people ate livestock feed to survive. Wild and escaped sunchoke patches provided nutrition to people who had no other options. The plant couldn't be blockaded because it couldn't be controlled. It was simply there, growing wherever it had taken root. The Second World War brought more devastating food disruptions across occupied Europe. In France, where German forces requisitioned enormous proportions of the food supply, families turned to whatever remained available. Sunchokes, called topinambeur in French, became a survival staple for millions. In the Netherlands during the catastrophic hunger winter of 1944, families dug frozen ground with bare hands searching for any edible root. These circumstances left a lasting mark. For a generation of European survivors, sunchokes carried the emotional weight of the worst years they had lived through. After liberation, many refused to eat them again. The vegetable disappeared from restaurant menus, cookbooks, and market stalls. Not because it had failed anyone, but because it was too closely associated with suffering. That psychological exile lasted for decades. Setting aside history and emotion, the nutritional profile of the sunchoke is genuinely impressive. The defining compound is inulin, a prebiotic fiber that makes up 50 to 60% of the tuber's dry weight. Unlike starch, inulin passes through the stomach undigested and reaches the colon intact, where it feeds beneficial bacterial populations, particularly Bifidobacterium species. The metabolic byproducts of this fermentation, short-chain fatty acids, support gut lining integrity, immune function, and mineral absorption. For people managing blood sugar, this matters considerably. Where potato starch converts rapidly to glucose and triggers sharp insulin responses, inulin from sunchoke is metabolized slowly and gently. Research and clinical observation have consistently shown that diabetic patients who incorporate sunchokes into their diet experience more stable blood glucose levels than those consuming equivalent calories from conventional starchy vegetables. The inulin that makes sunchokes nutritionally superior is also responsible for the flatulence problem that has followed the plant throughout its history. Gut bacteria adapted to processing inulin handle it well. Gut bacteria that have rarely encountered it produce gas as a byproduct. The solution, cooking longer to convert some inulin to fructose, or introducing the food gradually, requires patience that industrial food culture generally doesn't accommodate. Alongside inulin, sunchokes provide meaningful quantities of potassium, iron, copper, magnesium, and B vitamins. At 73 calories per 100 grams with 2 grams of protein, they deliver genuine nutritional density rather than empty carbohydrates. Beyond nutrition, sunchokes offer something most food crops don't: genuine benefit to the land they grow on. As a perennial, the plant never requires tilling. Its deep root system fractures compacted soil layers over time, improving drainage and structure. The extensive underground network creates habitat and food sources for soil microorganisms. Because the plant returns from root fragments rather than planted seed, the soil surface remains undisturbed year after year, maintaining the fungal networks and biological communities that make soil genuinely productive. In marginal or degraded ground where annual crops struggle, sunchokes frequently thrive. They tolerate temperatures down to minus 30 degrees Celsius. They survive drought conditions that would eliminate most vegetables. Where climate variability is increasing the unpredictability of growing conditions, a crop that produces reliably under stress represents genuine food security rather than theoretical abundance. The sunchoke never disappeared entirely. It persisted in roadside patches, permaculture gardens, farmers markets, and the kitchens of chefs who rediscovered its nutty, sweet flavor. Creamy when roasted, crisp when eaten raw, richly flavored in soups and purees. But it never reclaimed the place it once held in agricultural thinking. That may be changing. As growing conditions become less predictable, as the costs of conventional agricultural inputs rise, and as interest in perennial food systems grows, the sunchoke's particular combination of traits, high yield, zero replanting cost, soil improvement, drought tolerance, cold hardiness, looks less like a historical curiosity and more like a practical answer to real problems. 3 tubers planted this autumn will return as 30 next year. The year after, more still. The knowledge required to grow them fits in a single sentence. The ground has been holding this abundance in reserve for centuries. It's still there, waiting to be claimed.